Hello, Algebra 3-4 students. This is your Module 4 test review. I figured I would make a video going over the review to help you get prepared for your test. So the first 4 questions deal with writing equations for parabolas. So there's 2 different types of equations that you're going to choose from. And I'll write that down here to make that go all the way across. So you have 2 choices. You have x minus h quantity squared equals 4p, and then y minus k. Or you have y minus k quantity squared equals 4p x minus h. The difference between the two is the first one you use for parabolas that open up or down, and the second one you use for parabolas that open to the right or to the left. So for number 1a, it's helpful if you actually plot those points. So I'm going to go ahead and graph my vertex and my focus. So my vertex is at 2, 1. My focus is at 2, 5. And what I need to be able to write the equation is I need 3 things. I need my direction, my vertex, and the p. So p is the distance from your vertex to your focus. It's also the distance from your vertex to your directrix. So your vertex and your focus are 4 units apart, so that means p is 4. The parabola always opens towards the focus, so this one is opening up. Now if your parabola were opening up, if your parabola were opening down or to the left, you would have to make p negative, but you don't have to do that for this one because it's opening up. I have my vertex. My vertex is hk, so now I can go ahead and write the equation. So I have x minus h quantity squared equals 4p y minus k, and then that leaves me with x minus 2 quantity squared equals 16 times y minus 1. And there's your equation for number 1. Letter B, I'm going to do the same thing. It's helpful to actually graph. So my vertex is at negative 3, 3. There's my vertex. My directrix is x equals 2, so that means it's going to cross my x-axis. So there's your directrix. So your parabola is opening away from the directrix, so that means this parabola is opening to the left. P is the distance from your vertex to your directrix. So my vertex and my directrix are 1, 2, 3, 4, 5 units apart. So P is going to be negative 5, and I'm making that negative because my parabola is opening to the left. I already have my vertex. There's my H and my K. Since it's opening to the left, that's going to be y minus k quantity squared equals 4p and x minus h. And then that leaves me with y minus 3 quantity squared equals negative 20 x plus 3. So that's 2 examples where I give you the vertex and the focus as well as the vertex and the directrix. The next 2 is when I give you the focus and the directrix, so I'm not giving you your vertex at all. It's still helpful to actually graph. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my focus at 4, 9. My directrix is y equals 1, so that means it crosses my y-axis at 1. It's opening towards the focus and away from the directrix, so that means your parabola is opening up. So I have my direction. I still need to figure out what P is. Now P is the distance from your vertex to your focus, as well as the distance from your vertex to your directrix. But if I give you the focus and directrix, I can find this entire distance and then cut it in half. And then that's what P would be. So to go from y equals 1 to 4, 9, that's 8 units. So if I cut that in half, that means P is 4. So I can go 4 units away from the focus, 1, 2, 3, 4, and that's where your vertex would be. So your vertex is the ordered pair 4, 5. And we need to find the vertex because you need that to be able to write the equation, because that's your h and your k. So now I have x minus h quantity squared equals 4p y minus k. So that's x minus 4 squared equals 16 times y minus 5. And then for letter D, again, I'm going to start by graphing it. So there's my directrix. My focus is -7, -4. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So there's my focus. So this one is opening to the left. And then I'm going to go ahead and count the distance across from my focus to directrix. So going from -7, 4 to x equals 3, that's 10 units. So p is going to be half of that. So p is 5. Now again, since my parabola is opening to the left, I'm going to go ahead and make that p negative. I still need to find my vertex, so I need to go 5 units away from my focus. So 1, 2, 3, 4, 5, and that's where your vertex is. So your vertex is at -2, -4. So it's opening to the left, so I have y minus k squared equals 4p, and then x minus h. So y plus 4 quantity squared equals -20, and x plus 2. Alright, so that's writing equations for parabolas. The second thing that we did with parabolas was to actually graph it, so that's what number 2 is. So letter A is already in standard form, so I can go ahead and start by finding p. So the number in front of your parenthesis is equal to 4p, so I have -12 equals 4p, so p equals -3. Now if you look at this, your y is being squared, so that means it opens to the left or to the right. Since my p is negative, that means my parabola is opening to the left. The vertex, you have your x-coordinate and your y-coordinate. Your x-coordinate comes from the x, y-coordinate comes from the y. Don't forget when you're taking them out of the parenthesis, it's always the opposite, so your vertex is at 1, 2. So I'm going to start by plotting my vertex at 1, 2. There's my vertex. I need to move 3 units to the left. 1, 2, 3. And there's your focus. So when I move 3 units to the left, that changes my x-coordinate. So I'm taking 1 and moving it 3 units to the left, so that puts me at -2, 2. And then I can go 3 units in the opposite direction. 1, 2, 3. And there is your directrix. And that is at x equals 4. Now to be able to actually sketch the graph to make it the appropriate width of your parabola, you need to figure out your latus rectum. So your latus rectum is the number in front of the parenthesis, but it's always positive because we're talking about distance, and that's 12. So what I'm going to do is from my focus, I'm going to go 6 units away in both directions. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that gives me 3 points to be able to sketch your parabola. And there is your beautiful graph. For letter B, this equation is not in standard form, so we need to get it into standard form. So I'm going to start by moving over the variable and the constant, and you're moving over the variable that is not squared. So in this case, your x is squared, so I'm going to leave my x's on one side and move everything else to the other side. So I'm going to add 16y to both sides. I'm going to add 71. And when I rewrite my equation, I'm going to go ahead and insert my boxes. So I have x squared plus 6x plus a box equals 16y plus 71 plus a box. The number that goes in the box is half of your middle term half of your middle term and then square it. So half of 6 is 3, 3 squared is 9. And then this side we can go ahead and factor. That factors to x plus 3, quantity squared, equals 16y plus 80. And then I have x plus 3 quantity squared equals, I can factor out the 16, so that's 16 times y plus 5. And now your equation is in standard form. So once it's in standard form, I can figure out what p is. So I have 16 equals 4p, so p equals 4. Since it's positive and my x is being squared, that means my parabola is opening up. My vertex is at -3, -5. And then from my vertex, I'm going to move up 4 units. That changes my y-coordinate. So that now puts me at -3, -1. And you can also use the graph. So I'm at -3, -5. There's your vertex. I'm moving up 4 units. There's your focus. I go in the opposite direction 4 units. And there's your directrix. So that's y equals 9. -9. And then for the width of the parabola, you use the latus rectum, which in this case is 16 units. So that means from my focus, I'm going to go 8 units in both directions. So 1, 2, 3, 4, 5, 6, 7, 8. This one's not on the graph, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8. It's always from the focus, by the way, never from the vertex. And then you can connect, and there is your graph. So that is all of the material for your first learning target for 4.2. Your second learning target was to solve systems of equations. So we have 2 methods for solving systems. You can solve it by substitution or elimination. I just said to solve the system, but I also noted that some are already set up nicely for a particular method. So if you look at 1 and 2, both of them are already set up for substitution because you already have y by itself. So since y equals -3x plus 7, I'm going to substitute my y in the second equation for -3x plus 7. So I have 4x plus 2 times -3x plus 7 equals 16. Go ahead and solve for x. I'm going to distribute. So that's 4x minus 6x plus 14 equals 16. Combine like terms. Subtract 14 from both sides. Divide by -2, and you get x equals -1. And then from there, I can take that and plug it back into my equation. So I'm going to plug it back into the one that I circled. So now I have y equals -3 times -1 plus 7. So I get y equals 10. So my ordered pair is -1, 10. For number 2, same thing. I'm going to do substitution. Since y equals 5 minus 2x, I can substitute my y in the second equation for 5 minus 2x. So I have 3x minus 3 times 5 minus 2x equals 3. Distribute. Keep in mind you're distributing a -3. Combine like terms. Add 15. Divide by 9. So you get x equals 2. And then I'm going to substitute that back in. I like to use my circled one to solve for y, so I have y equals 5 minus 2 times 2, which is 1. So my ordered pair for this is 2, 1. So I chose elimination, or not elimination, substitution for both of those because it was already set up with the y equals. For 3 and 4, you can really do substitution or elimination, it doesn't matter, but these two are set up nicely for elimination, so I'm going to go down that route. I'm going to go ahead and eliminate my x's. So to eliminate your x's, you need the same number and opposite signs. So I'm going to multiply my 2 by negative 3. That way I have a negative 6x and a positive 6x. So that's negative 6x plus 3y equals negative 21. And my second equation I'm not doing anything with. And then I can go ahead and add the two equations together. So my x's cancel, my y's also cancel, so that leaves me with 0 equals negative 7. Well, 0 is never going to equal negative 7, so that is false. So that means this one has no solution. For number 4, I'm going to go ahead and eliminate my y's. So to eliminate my y's, I'm going to multiply my first equation by negative 4. That way I get a positive 12 and a negative 12. So I have negative 4x minus 12y equals negative 8. My second equation I didn't do anything with. And let's go ahead and combine. So your x's cancel, your y's cancel, and look at that, your 8's also cancel. So that leaves you with 0 equals 0. Well, does 0 equal 0? Of course it does. That's a stupid question. So that means you have infinite solutions. So if you end up with a false statement like we did with number 3, then that is no solution. If you end up with a true statement like you had for number 4 where 0 equals 0, or you had like 5 equals 5, then that's going to be infinite solutions. You do have a word problem that's on your test, so here's a couple word problems to give you some practice. So at Superdog in Chicago, a hot dog and 2 sliders cost $5.50. 2 hot dogs and 3 sliders cost $9.50. How much does 1 hot dog cost, and how much does 1 slider cost? So like we talked about in class, it's important to specify what your variables represent. So I'm going to let h equal the cost of a hot dog. And s equal the cost of a slider. Okay, so it says a hot dog and 2 sliders cost $5.50. So I have 1 hot dog plus 2 sliders equals $5.50. And then it says 2 hot dogs and 3 sliders cost $9.50. So 2 hot dogs plus 3 sliders equals $9.50. So once you have your system set up, you can go ahead and solve by substitution or elimination. It does not matter the route that you choose. I'm going to go ahead and do elimination, and I'm going to eliminate my hot dogs. So I'm going to multiply the first equation by negative 2. So that leaves me with negative 2h minus 4s equals negative 11. 2h plus 3s equals 950. My hot dogs eliminate. That leaves me with negative 1s equals negative 1.5. So that means s equals positive 1.5. And then I'm going to take that and plug it in to figure out the cost of a hot dog. So I have h plus 2 times 1.5 equals 5.5. So you get h equals 250. Now since we are dealing with a word problem, you do have to write your answer out in words. So that means a hot dog costs $2.50 and a slider costs $1.50. So again, don't forget to write your answer in words. Alright, number 6. Mountain Pointe's theater company put on a play. Adult tickets were $10 and student tickets were $7. If they sold 325 tickets and made $2,500 in ticket sales, how many of each type of ticket were sold? So I'm going to let A equal the number of adults and S equal the number of students. So they sold 325 tickets, so that means if I take my number of adults plus my number of students, it should equal 325, and it was $10 for adults, $7 for students, and they made $2,500 in sales. So there's your system. This one I'm going to solve by substitution again, elimination again. So I'm going to multiply my first equation. I'm going to go ahead and eliminate the students. So I'm going to multiply the first equation by -7. So that's -7a minus 7s equals -2,275. And then I have 10a plus 7s equals 2,500. Let's go ahead and add our two equations together. Students eliminate. That leaves me with 3a equals 225. So a equals 75. And go ahead and solve for the number of students. So I have 75 plus s equals 325. So that means s equals 250. So we had 75 adult tickets were sold and 250 student tickets were sold. Sorry about the crappy handwriting. But there you go. Again, don't forget to write your answer as a sentence. So that covers everything for your second learning target, which was solving a system of equations. Your last learning target was to solve linear and quadratic systems. So you're still solving systems, it's just that now you are working with a linear and a quadratic. So there's two different types of questions. You have problems 1 and 2, and you also have problems 3 and 4, which are structured a little bit differently. But 1 and 2, both of those have both equations set up so that y is already by itself, so I can solve by substitution. So I have x squared plus 12x plus 9 equals 4x minus 3. And anytime you're solving a quadratic function, you always want to get it equal to 0. So I'm going to go ahead and subtract 4x and add 3 to both sides. So that leaves me with x squared plus 8x plus 12 equals 0. So two numbers that multiply to 12 and add to 8 are 6 and 2. So I'm going to factor it, so that's x plus 6 and x plus 2 equals 0. So that means my first solution for x is -6, and my second solution for x is -2. Whenever you're solving, you need both an x and a y, so I'm going to go ahead and solve for y for both of those x's. So I have y equals 4 times -6 minus 3. That's -27. So your first ordered pair is -6, -27. And then I have y equals 4 times -2 minus 3, which is -11. So my second ordered pair is -2, -11. So then you have two ordered pairs. I'm going to do the same thing for number 2. Substitution. So I have x squared plus 8x plus 18 equals negative 6x minus 6. I'm going to add 6x and add 6 to both sides so that my equation equals 0. So that's x squared plus 14x plus 24 equals 0. Two numbers that multiply to 24 and add to 14 are 12 and 2. So my factors are x plus 12 and x plus 2 equals 0. So my two solutions for x are negative 12 and negative 2. Still have to solve for y, so I'm going to take each of those and plug them in. So I have y equals negative 6 times negative 12 minus 6. That is 66. So my first ordered pair is negative 12, 66. And then I have y equals negative 6 times negative 2 minus 6, which is 6. Lots of 6's in here. So that's negative 2, 6. So there are your two ordered pairs for number 2. Numbers 3 and 4, they are linear quadratic systems, but they are structured differently. So I tried to give you some hints so you can still work with it. So the first hint is to solve the second equation for x and then substitute it into the first equation. So I'm going to solve the second equation for x by subtracting y from both sides. So that leaves me with x equals negative y minus 6. So now that I know that x equals negative y minus 6, I can go ahead and substitute my x in my first equation for negative y minus 6. So now I have 2 times negative y minus 6 plus y squared equals 12. I'm going to go ahead and distribute the 2, so that's negative 2y minus 12 plus y squared equals 12. Your second hint says to rearrange and solve by factoring. So I'm going to rearrange this and then get it equal to 0. So I have y squared minus 12y, or 2y, minus 24 equals 0. So two numbers that multiply to negative 24 and add to negative 2 are negative 6 and 4. So my first possible solution for y is 6, and my second possible solution for y is negative 4. I'm going to take both of those and plug them into my circled equation in pink up there. So I have x equals negative 6 minus 6, which is negative 12. So my first ordered pair, my x is negative 12 and my y is 6. So make sure you write it with x first. And my second ordered pair, I have x equals negative 4 minus 6, which is negative 2. So my ordered pair is negative 2, negative 4. Again, just make sure that you write it with x first. Number 4, I'm going to do the same thing, so I'm going to solve for x. So I'm going to subtract y from both sides. So that's x equals negative y plus 5. Going to go ahead and make a substitution. So I have 3 times negative y plus 5 plus y squared equals 55. I can distribute the 3. I can rearrange. Get it equal to 0. And then solve by factoring. So two numbers that multiply to negative 40 and add to negative 3, that is negative 8 and positive 5. So my first solution for y is 8. Second solution for y is negative 5. Now I still need to solve for x. So I have x equals, just plugging it back into the one I have circled in pink. So negative 8 plus 5, which is negative 3. So my ordered pair is negative 3, 8. And then my second value for x is negative of negative 5 plus 5, which is 10. So my ordered pair is 10, negative 5. Alright, so the last thing you were doing with linear quadratic systems was to look at the graphs. So which line intersects the parabola shown below in exactly 2 points? So we need to graph all 3 of these lines, so I'll try to color coordinate. So A will be in blue, or that's definitely not blue, that's pink. A will be in pink, B will be in green, and C will be in blue. So the pink one, x equals negative 2, that means I'm going to go to negative 2 on my x-axis, draw my line. And you want to see how many times it touches your graph. It only touches your graph in one spot. And we want to see which line intersects the parabola in exactly 2 points, so it's not the pink one. Let's go ahead and do the blue one. So the blue one, I have y equals x plus 2, so I'm going to start at 2. And then my slope is 1, so I'm going to go up 1 over 1, up 1 over 1. Go in the opposite direction as well. This line doesn't cross the parabola at all, so it can't be letter B, so it has to be letter C, just by eliminating the other 2, but let's go ahead and graph it anyway. So I have negative x minus 2, so my y-intercept is negative 2, my slope is negative 1, so from negative 2 I'm going to go down 1 over 1. I'm going to go ahead and do this in both directions. Hopefully your lines are a little straighter than mine. That was pretty wavy. But you can see that it crosses in 2 spots. So your correct answer is letter C. Alright, so that concludes all of the material for your Module 4 test. Good luck studying!